2 minus 1 over x plus 1, x squared plus x. So what I want to do is go ahead and factor everything I can before I start. And the only thing I see that I can factor is this last one here. And I can take an x out of there. And that's just going to help me form my LCD a little bit easier. So now whenever I try to do my LCD over here, I take the first denominator, which is 1, so that doesn't matter. The second denominator, what else do I need in my LCD? An x. That's exactly right. I don't have to repeat this factor because it's already in there one time. All right, so now I give everybody what they need. This one needs everything, so it needs an x and an x plus 1. X and an x plus 1. How about this one? X. And this one's got everything it needs. So now I can drop the bottoms off, and I can just solve from the top. So I have 2x times x plus 1 minus 1 times x equals 1. So that's 2x squared plus 2x minus x equals 1. I'm going to combine the two x's and move that 1 over. So now the question is, can I factor that? Does anything multiply to negative 2 but add to positive 1? Negative 1 and positive 2. 2, I have 2x squared minus x plus 2x minus 1. We got an x. We got a 1. So my two solutions here are negative 1 and 1/2. But I have to check them to make sure they're not extraneous. So the original equation is number 11, yeah, which is 2 minus 1 over x plus 1 equals 1 over x squared plus x. Negative 1's pretty easy to check, right? I get 2 minus, and I'm already in a situation of a 0 on the bottom, which means that's extraneous. Everybody sees why? You ever get to that situation, you're extraneous, you don't have to go any further on that one. 1/2, 2 minus 1 over 1/2, 1/2 squared plus 1/2. A 1/2 plus 1 is 3/2. So this is 2 minus, if I'm 1 over a fraction, what do I do? Reciprocal it. 2 minus 2/3 would equal 1 over. A quarter plus a half would be, y'all can do that, 3/4. Thank you, Dylan. 2 minus 2/3 would be, you have 2 whole and you take away 2/3, what do you have left? 1 1/3. Flip that one around, 4/3. Is that the same thing? So that is a good solution. So one extraneous and one real. To be doing that again, it doesn't work when you plug it back in. It's an imaginary solution or not a real solution. You did, you just, yes. Yeah. 29. X squared plus 5 over x equals 8. What's my LCD? X. So this one needs an x. This one needs an, nothing. This one needs an x. So I can drop the denominators off and solve from the top. This is the one I actually told third block I forgot to tell y'all. Sorry. You can only solve this with a calculator at this point. So graph it and find the zeros. Make it equal 0, so you'd have x cubed minus 8x plus 5. And if you're solving with the calculator, you're only finding the real solutions anyway. You're not going to see extraneous solutions. 19 through 22? Yeah. Does it matter which one? So 19 gives me this graph. It looks like it's crossing at 1, 2, 3, 4, -5. Looks something like that, and then like this. And it says, given x equals -5 or x equals -2, which one is extraneous? Why? It doesn't cross there. It never crosses at -2. It does cross at -5, so it's a real solution. Ashley said 23. Are y'all making Noah get all the trash? I wouldn't tell him to. He just did it. I'm going to go ahead and put these over 1. What's your LCD here? X minus 1. Because, so, I take the first denominator, which is x minus 1, right? And then I include any pieces from the other denominators that are lacking, but they're just 1, so I don't need anything else there. At this point, we wait. Sorry. I can drop the denominators off and just solve from the top. So 2 equals x, oh, no, not equals. 2 plus x times x minus 1 equals 5 times x minus 1. Bless you. And get it all on the same side. So minus 6x, and then add the 5. I would have plus 7. World. And that can be factored. This is 23. Yes. When? Well, we've been out a week. When was the last time you got lectured in calculus? Now check for extraneous. So plug back in. 2 over x minus 1 plus x equals 5. This is an easy one to check. If I do 6, I have 2/5 plus 6 equals 5. Is that true? No. What? Did I do something wrong? You're right. Oh, I do suck at that one. So this one does not factor. I apologize. Which means what? Sorry. 4 times A times C. You wish you had made a song? You didn't make a song? Really? But everybody who made a song remembers it, don't you? You do remember it from your song? $23. What's that tell me? So they're both going to be extraneous. So no real solutions there. Yeah. Oh my gosh. Stop distracting me about quadratic formula songs. I looked at 6 and multiplied by. It's not my thing today. Sometimes. Some days. What is that now? 8? We're moving on from this problem. I'm ready to review you for your test. Thursday. Today and tomorrow. Because it's actually all of chapter 2. I'm going to go back. So I'm going to do this review a little bit differently than what we've done before. I'm not going to give you a review that looks exactly like the test. Because then you just regurgitate it. That's definitely a real word. It's definitely a real word. I don't know. I can't define it. Spit it back out. Spit it out. Right. I'm not the worst speller in the world. I'm not the best either, but. So what I am going to do is I'm going to give you some topics. I'm going to give you a list of things that you need to know how to do, and I'm getting this straight from the test. Past that, then I'm going to give you practice problems to do. Go with me? You might want to write this down. Long division. Polynomial long division. If you give me my book back. No, it's okay. No, it would not take. So this is for chapter 2. In behavior, limit notation. Yep. Write an equation of a polynomial given factors. So if I told you to, I'm going to say factors or zeros. If I told you that 5 and 3 plus I are factors of a polynomial, write a polynomial with our zeros of the polynomial. Yes, this means that x minus 5 is a factor, and x minus x minus 3 minus 5. You have to multiply it out. It's got to be in standard form, so you'll multiply it out. You can, or you can distribute the minus sign through. It's up to you. Of imaginary solutions, yes. It's only opposites of imaginaries. Bye, y'all. Y'all okay there? Given the zeros, write the polynomial function. You do have a couple multiple choice intertwined on here. Yeah, can you believe it? A little bit. Be able to find all vertical and horizontal asymptotes. And that's a little bit heftier topic than what it seems there, right? Yeah. The whole thing is non-calculated. Everything will be able to be done without a calculator very easily. But you're gonna let us use our calculator. No calculator on this. Oh, can we? I'm not taking it seriously. I will use it. What are you accomplishing by doing that? What are you accomplishing? Because this is pre-calculus, and in calculus, half the course is non-calculator. So I have to teach you to do things without a calculator. You're not. Well, sorry. You're in pre-calculus, so no calculator on this one. This one, I created this test so that it could easily be done without a calculator. There's nothing that is going to... I don't even think it would be easy to use this one is. No, so here, remember vertical asymptotes happen when the bottom is 0, as long as factors don't cancel out. When factors cancel out, what do you end up with? Y'all are thinking horizontal asymptotes. I'm talking vertical. There you go. It's a whole. It's a whole. So if I have x plus 2, x minus 1 over x minus 1, x plus 3, this is my whole because it cancels. This is my vertical asymptote at -3. So you plug in a 0 for the x. You won't have to. You won't have any that. No, everything can be done without a calculator. Horizontal asymptotes is when I'm looking top heavy, bottom heavy, or same. Okay. Remember, if it's top heavy, that's when I have a slant. Okay. So to find the slant, I divide and ignore the remainder. If it's bottom heavy, it's like if it's okay. So if it's top heavy, it's a slant. There's no horizontal asymptote. This is when I divide and ignore remainder. If it's bottom heavy, the horizontal asymptote is 0. And if they're the same, what is it? Leading coefficient at the top divided by leading coefficient at the bottom. You will have some you'll have to sketch by hand. I'm going to tell you. You won't have one that has more than one slant. Make sure you understand that these are given as equations of lines. So here the vertical asymptote would be x equals -3, and the horizontal asymptote or the slant asymptote would be in the form of y equals whatever that value is. What do you mean? No, correct. That's right. That's right. And I'm going to run you through everything for you. All right, questions so far? That's questions 1 through 4. Well, some of them, and then I combined some of them into graphs. There's 13. How do you use the remainder theorem? What is the remainder theorem? Remainder theorem, what's it say? How could you determine the remainder using the remainder theorem? Plug in the value. Okay, so if I asked you, if I gave you this. Yes, this is another one, Bliss. If I gave you an equation and I said, what is the remainder when you divide by x plus 7, right? If I plugged in -7, that would tell me what the remainder is. So make sure you do that, because if I specifically say, use the remainder theorem to find the remainder, I don't want you to divide. I want you to use the theorem that says, if I plug in, I get the remainder. And it gives you the remainder. Yep. If it says use the remainder theorem to find the remainder, that's when you plug in. If I said, yes, it'll be, this was a, I mean, I'm going to use like ones or twos. I mean, it won't be anything that the point is that you understand remainder theorem means plug in to get the remainder. I promise I'm not going to let you think on calculations here. That's not the point of this. No, this would say if I have f of x equals, I don't know, 25x to the 12th plus 16x to the third, whatever, then to find the remainder, I would plug -7 in for the x's, and it would give me the remainder. Opposite sign. What?
Number you got for that over x plus 7?
No, the remainder would just be. Yeah. What's the remainder thing when you do the synthetic division? You can do that whenever you divide, and that's why I said you could technically do that here to get the remainder, but I don't want you to do that. I want you to use remainder theorem by plugging in. Yeah. The opposite sign. Right. Well, I mean, technically, your whatever this remainder is, that's your you put it over x plus 7. But this is what I'm looking for here. No, it'll just be a value. It'll be a value. Not okay. What does AROC mean? Average rate of change. Go for it. All right. If it's the average rate of change, if it's literally, it will literally say the rate of change, or it will give you two values that you're finding the rate between, and you're just writing the equation of a line based on 2 points. Okay, you're finding the slope. This is really slope. And you'll go, I'm gonna give you several of those to practice with too. Do you remember I can't remember. I think we called it defense problem. What was the problem we did? I just remember the example. Well, technically, I don't have to give you. I'm giving you specific examples that look exactly like the ones from the test. And I remember us doing one in class. No, I don't want to do that. Kind of like the box problem. Yes, that's what I was trying to think. No, you have done it. Yeah. All right. So whenever, go ahead. Yes. It's just, well, instead of volume, it could be area. It could be a little easier than box. but be able to do the box problem. Yeah. Okay, if you can do the box, you can do this. But make sure you go back and look at that box problem where we have this is x and this is x, and we have some number value here and some number value here. We said volume was length times width times height, right? If I'm looking at area, it would be length times width. Okay, so be able to do that. Why you are looking at me like that, Brett? Linear factorization. How do you do that? I'm positive. I'm 100%. We actually spent like 2 days in that. That's whenever we are breaking down and every factor is just, where did it go? So these are all x plus something, x minus something. They could include imaginary. Remember, you'll need to include those imaginary. So you'll have to find the zeros to write the linear factorization. Might need to use PRZs. So you need some of the zeros to find the linear factor. If it won't factor down any further, it may be that you have to find those zeros and then use those zeros. So like if I went through maybe a quadratic formula and I found out that 2i was one of the zeros, then I would need an x plus 2i, and of course the x minus 2i would need to be in there also because you have to include those, and that would be the linear factor if it doesn't factor. You will need to be able to write the equation of a parabola given the vertex and a point. So you will need to know vertex form there. Remember that is a times x minus h squared. You will plug in the point, you will plug in the vertex, and you'll solve for a to get your equation. And then let's see. One transformation graph from a monomial one of the parent functions we have talked about before. You will do the transformations on that.
Please pardon this interruption. At this time, all remaining freshmen who need to make up pictures should report to the auditorium. That is all remaining freshmen. Thank you.
You will do the transformations. You will graph it precisely. And you will do the domain and range on that. Yes. No, domain and range does not, that's interval notation. In behavior's limit notation. And then for the biggie, you will have one that is just a rational function, something over something, okay? Maybe we'll say a polynomial over a polynomial. For this, you will have to find the x and y coordinates. And I'm not going to write all this. If you want to jot it down, you can. You will have to give the equations of the horizontal and vertical asymptotes. X and y intercepts. Horizontal, vertical asymptotes. And then I'm just going to read you the last part because I think that it will help you understand what it is that I'm trying to get you to do here. Using your knowledge of in behavior, leading coefficients, and multiplicity of factors. What does multiplicity mean? Repeated solutions, if it's even, what does it do? Bounces. If it's odd, goes through. Using all of that, along with the intercepts and asymptotes that you found at the beginning of the question, sketch as accurately as possible, because you do not have your calculator, a graph of the function and give the domain a range. So you're going to use what you find, sketch. Everybody's will not look the same. Everybody's is going to look a little bit different. But this is so that you can interpret everything you know. And this is kind of the put it all together question. Well, you would have to like factor it to see what the multiplicity was. You see what I'm saying? If it had multiplicity. Yes. And that's going to happen at zeros, and zeros happen when what? The top equals 0, right? Because x-intercepts are when the function itself equals 0, and that's going to happen when the top equals 0. The bottom equals 0, that's going to be undefined. That's going to be your vertical asymptotes or your whole. And then you have two questions like what you did last time, where we found the LCD to solve the equation. You do have a bonus. I won't tell you what the bonus is, but there is a bonus. It's an actual bonus. What, the bonus? It's on one of these things, but it's a difficult one. Not difficult computation-wise, just difficult to do. All right, let me give you your work. I'm going to let you get started. Does anyone have any questions before I start you? All right, we're going to do page 214. I skipped over a lot of this stuff, so I'm not going to give you things that aren't going to look. Let's do 3, 5. These are matching that 49 through 52, so you're looking at multiplicity and things like that. If you need more help with any one particular topic, I'm just kind of cherry picking through. I know I'm not done. Thank you for that, Bill. That's your grade.